How old is the universe? It is difficult to imagine that only 90 years ago we did not know about the existence of most of the universe around us. In fact, most astronomers thought that the Milky Way contained all the stars in the universe. In 1917, Heber Curtis witnessed a nova, a sudden burst of brightness resembling a new star within what was then referred to as the Andromeda Nebula. Novas typically emerged swiftly and then gradually dimmed over weeks or months. This intrigued Curtis, and he began looking for more novas in photographic records. He discovered 11 more of them. But what really got him curious was when he noticed that novas in Andromeda were drastically fainter than novas in the Milky Way. Based on this, Curtis was able to estimate that Andromeda was 500,000 light-years away. As a result, he became a proponent of the so-called island universes hypothesis, which held that objects previously believed to be spiral nebulae within the Milky Way were actually independent galaxies. This was a revolutionary step for mankind in cosmology, but we still assumed that the universe was static. Albert Einstein even added something called a cosmological constant to his equations to make sure the universe stayed still. Cut to 1928, and Edwin Hubble's measurements of galaxies led him to the realization that the universe was uniformly expanding. This observation implied that the universe possesses a finite age, and this age could be estimated by mathematically going back in time. With this, Edwin Hubble first estimated the universe to be only 2 billion years old, which now we know is way off from the universe's actual age. The discovery of the cosmic microwave background radiation announced in 1965 finally brought an effective end to the remaining scientific uncertainty over the expanding universe. While we were now sure that the universe was expanding, its true expansion rate continued to be a mystery. Over the next few decades, uncertainty surrounding the actual expansion rate sparked a vigorous debate, with estimates ranging from 8 billion to 18 billion years. The dent in the calculations showed up more pronounced when scientists began to calculate the ages of the oldest main sequence stars and found that they were more than 8 billion years old. Logically, there cannot be stars older than the universe itself, and this brought us to a dead end in cosmology. In came the Hubble Space Telescope, and in 1997, its observations triumphantly broke that dead end by announcing that the universe was not expanding at a constant rate but accelerating due to an unknown repulsive force termed as dark energy. When dark energy is factored into the universe's expansion history, astronomers arrive at an age for the universe of 13.8 billion years. But there is a problem. A parameter used in cosmology to describe the rate at which the universe is expanding, called the Hubble constant, still remains up for debate. Based on fundamental physics and the cosmic background radiation, scientists believe the Hubble constant should be around 68 kilometers per second per megaparsec, but this doesn't match up to observations of the actual stars and galaxies astronomers see around our immediate vicinity. So that raises a question. What if everything we thought we knew about our universe's age is only a partial truth? Brace yourself, for here is a shocking discovery. A group of stars in the Milky Way appears to be as old as the universe, or maybe older. Star Cluster M92, a densely packed ball of stars roughly 27,000 light-years from Earth, is about 13.8 billion years old. The newly refined age estimate makes this clump of stars the same age as the universe. This could break the current age of the universe and put a limit on it, thereby helping solve cosmic conundrums about how the universe evolved. The age is on the edge, as estimated by other groups, said astronomer Martin Ying of Dartmouth College. It helps us set the lower bound of the age of the universe. We don't expect the star cluster to be born before the universe, right? Globular clusters such as M92 consist of densely packed groups of stars believed to have formed simultaneously, simplifying the task of determining their ages. For astronomers, stars follow different life paths depending on their mass at birth. Larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars endure for longer periods. Understanding how many stars in a cluster have transitioned beyond their primary fuel-burning phase provides insights into when the entire cluster originated. However, age estimations traditionally rely on assumptions about stellar evolution. Seeking a more reliable method, Yang and colleagues employed a computer to generate 20,000 synthetic stellar populations for M92, each representing a potential cluster age. They then compared the colors and brightness of each population with observations from the Hubble Space Telescope, determining the age that most closely matched the collected data. While M92's age has been measured before, previous estimates depended on a single synthetic star collection. By comparing thousands of synthetic populations, the researchers significantly reduced the uncertainty associated with assumptions inherent in each model. This novel technique resulted in a 50% reduction in the uncertainty of the cluster's age. The team determined that M92 is approximately 13.8 billion years old, with a margin of error of around 750 million years. Remarkably, this age aligns closely with the best estimate for the age of the universe, slightly over 13.8 billion years, with an error margin of approximately 24 million years. One way around that tension is to accept a different age for the universe. If one takes the Hubble tension seriously, then one also has to say we don't know the age of the universe that well. This discovery puts the lights back on the recently published University of Ottawa study that claims the universe is not 13.8 billion years old, but 26.7 billion years old. But to basically sum it up, the new model stresses the existence of stars like Methuselah, which appear older than the universe's estimated age, and the discovery of early galaxies with the James Webb Space Telescope. These early galaxies, observed only 300 million years after the Big Bang, exhibit levels of maturity and mass typically associated with billions of years of cosmic evolution, presenting a significant puzzle. But advancements in computing, theoretical understanding, precise measurements of cluster distances such as M92, and finding primordial galaxies at the Dark Age, what do you guys have to say? Is the universe older than 13.8 billion years? Do we need a new approach? Renowned physicist Michio Kaku had, in fact, called it a year ago that it might need to be tweaked now if it turns out that the universe is older than we think. Hey, Professor, I'm thinking of some of my favorites. The Equation, Physics of the Future, Future of Humanity. Most of them say the universe is about 13 billion years old. What if it's not? Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy like the Milky Way, a galaxy with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only 500 million years old. Something is wrong. We may have to revise our theory of the creation of the universe.